expressions. Okay. So if this is what we started with. Okay, so I'll just use number 14 there. You were given an expression, and you were asked to simplify it, right? Yeah. So you go through the steps. So that will be changed to sine and cosine. Right? And then we do some fraction math. My computer. Algebra. Get 1 over cosine. And that is secant, right? And that's an identity. Sweet. Come on, computer, keep up. Right. So that would be simplifying an expression, correct?
Yes.
Here's how we verify identities. It might say something like prove cosecant theta over cotangent theta equals secant theta.
Wouldn't it just be the same thing though?
It's the same problem, basically. See how we have start and finish? Right? So I'm actually giving you the answer.
Yeah.
You just have to fill in the middle.
Oh, okay.
Okay, so there's not a whole lot of difference between what we did Friday and what we did today, or doing today. So in this case, we're just going to do math until we get these two set equal to each other. Okay. If you have a simple expression on one side, I would suggest just leaving it. If they are complex, we'll mess with both of them.
Could the answer like be wrong? So like that was like cosine or something like that, and you'd have to prove that it wasn't right. Would that be something like that?
We did that last week. Remember counter examples?
Oh, well, yeah.
Show something is not an identity using a counter example. So in that case, we would just plug in unit circle values and see if it worked. Right? If it doesn't, not an identity. But the nice thing about these, it says prove this is true. That's what you gotta do. Okay? It's not gonna be one of those show a counterexample. It says prove this is true, you're gonna go ahead and do it. So we would follow the same work. Again, if it's pretty simple on one side, just leave it. Okay. And then this becomes, if you cancel those, 1 over cosine, right? And that we do know is okay.
Say they were set equal to each other, right?
Say what?
Say they were set equal to each, so two long equations were set equal
Right.
to each other. Would it mean that you'd have to solve them on both sides, or does that mean that the first side would have to be simplified down to that?
I would, if if you get two big long ones on each side, I would probably mess with both sides. Simplify each side until you get them equal to each other. Okay. All your algebra rules apply here, just like we've been talking about. Okay. Good. Let's see here, verify. Okay. Well, now you do that one.
This is 10 equals
I just did it. I could just.
Check your answer with a buddy. Tyler, you read your work on the board?
So just be coasting.
Okay, be careful, my computer's running slow.
I'm not sure I can work this board.
Yeah, they you just.
Let the board
Was
work.
Thank you, Tyler, I appreciate that.
For what, writing this?
Yeah.
Sorry.
Yeah, we're.
Equals 1 of C.
Okay, we have, can you follow it?
Yeah.
Is anybody still confused?
Yeah.
Okay, so, one of the things I suggested last week, be organized, right? Okay, so, I think you just don't know how to work the eraser. Okay. Right? So continue your equation, right? I would suggest keeping your variables. Just a small critique.
It's minimum critique.
It is. It really is. And then, just, I mean, again, staying organized, keep your equations all the way down. So you can see, I mean, directly see. Okay. So on your papers, remember the four things we talked about, right?
Yeah.
Or what are they?
Fraction.
Okay, we can use fraction math, right?
Algebra skills.
Gotcha.
Okay, that'll be algebra skills, yeah. Usually factoring. What else? Change to sine and cosine,
Identities.
which is also identities. Okay, so on your paper, next to each step, I want you to label which one of those was used. So from here to here, which one of those is used? Okay. And then second to third and third to fourth. What? Not necessarily. So like, take step one, what did he do?
That's identity.
Change to, yeah, using identity to change to sine and cosine. So put that right here, change to sine and cosine. Describe each step in writing.
And then use algebra to step through.
Is that connected? If not, I'll let you go, but it's the way to do it. Evan, what was step one? Which four of these, which one of those? Yeah, so again, we can lump these two together, right? We just separate out because we use that one so often. Change sine and cosine?
Yeah.
All right. Isaac, what step was that? Yeah, you're cross-canceling out fractions. And same thing here. Good. Question.
For step two to step three, which was, you said fractions, we use algebra.
It can be algebra too, yeah, I mean, just gonna look right here, there, no worries. Okay, you wanna see a harder one? We'll step it up just a little bit. Oh, let's see there. Okay, a little bit more going on here, right? So just a couple of them, we have several. until I get going.
Do the same thing, no, thank you.
So much less than just switching to
Michael, any ideas on a first step there? Okay, so what do we get?
Sub 1 over sin over cosine.
Okay, which is correct. Let's make that a little easier. It works.
Negative 2 cosine. And then it would be, that's 1 over sine.
Well done. Okay. Okay. So we changed to sine and cosine using the identities.
Cancel out signers, that we divide by signers and both top and bottom.
One step at a time. What did you say first? I'm okay with you going fast, but I want to.
Cancelled out sign.
Okay, here.
No, the divide by sign both cancelled out.
Interesting. Valid. I didn't think about that. Okay, so again on these you can see that you can take a couple of different ways, right? We talked about that Friday. Since I've already done this, do you want to continue it or do you want me to do it your way? Yours. I didn't bother me.
I'm going
Okay.
You can eliminate cosine.
Do what?
Eliminate cosine? I'm talking about that.
Can you?
Oh, no, it's not. Alright.
So come up with a reason why you could do that.
Because then we're going to go to the fractions.
Yeah, he's correct. If you have the same item in denominator or denominator, you can cancel them or numerators. You can also do your fraction division. Okay, copy that flip, right? And now, like you said, we end up here and you're done, right? Just make your equivalent statement. Okay. Partner up. I guess you can trio up if you need to. But one person at each set of tables, raise your hand, please. Great. Thanks, Christian. What about you guys? Be a group leader. There you go. Okay, so person that raised your hand, please describe to your classmates each step that was taken here using those 4 items. You need assistance, correct? You can do it either way, as long as you can see it.
I think the last two were fixed.
First thing is under the middle.
It's just weird because it's probably one of the it's just simple algebra. It's just remember. But we can fraction.
I did.
So you know what this means, right?
Yeah, it's homework.
Or practice.
Getting it. Yeah, it's getting it. Questions? I heard what I heard when I was wandering around. Sounded good?
Could I interject a quick story? So, just a funny story or something that you guys might learn from on this. So, I had a student once that I taught, and he is the smartest student that I've ever taught in my entire teaching career. And he could do math problems in chemistry and physics without going through all of these steps. Like, he could just see it. I mean, Jerry, you kind of did that, right? What do you think I said to him every time he did that? I told him, you have to show your work. You got to write the steps down. You have to explain why. You have to show your work. You have to show your work. Did he ever? Guess what happened to him when he got to college? He flunked out. Smartest kid I've ever taught, and he flunked out of CMU because he refused to do what you guys just did on the board.
That's a very academic example, right? I can tell you right now, again, to back that up, I worked on oil and gas wells for a year between Alaska and moving back here, and they wanted to see the data sheets. They wanted to see the work. Okay. Because there has to be some verification that you're doing it right. Because if you make a mistake, if I make a mistake on an oil rig and we put that drilling bit into the Bakken shale up above the sandstone, that thing sloughs off, pinches your pipe, you pull it, breaks off the $2 million tool set. You're probably getting kicked off the rig. Okay, so there is very much room in the working world for verifying your work. And we used trigonometry on those jobs like nobody's business. Angles, triangles, that's all we were doing. All right, so here's the work that we want to do. We're going to go over some harder ones tomorrow. Okay.
Where's the worksheet?
The worksheet is on Google Classroom. Should be posted. I will check. I'm going to write a couple of these on the board so those of you without books can start. Okay? Start. But this is not going to be due until Thursday. Depending on absences, it might be Friday, okay? So we're going to remain flexible on that end. Good? Okay, I'll write a few on the board for you to start if you want to go.
You have to be involved.
You know that writing we're supposed to do on Friday? There's so many people that were doctors like that. How's that weird? Yeah, Friday we're supposed to be doing a time essay. So many people didn't show up because of that. He's like, okay, we'll do one Tuesday now. So that's what we're doing.
I thought it was 6.
Yeah, we have 45 minutes left of that. Yeah, it is. Yeah, but we broke my heart.
Hey, we own the cross paper.
Nope. Thanks to me saying that. You guys were not saying first, you were saying no process paper.
I was going to say cross paper because I know they call
Okay, there's the first three. For the more straightforward ones, so.
What are you talking about? I'm just going to say it. Yeah, that's what I'm saying. Don't go to college. That's what he's telling me. I think it's better to call.
That's a good question.